Okay, so this morning we started talking about static equilibrium. Okay, so in simple terms, we said static equilibrium is attained when an object is static or not changing position, not moving, or just still. Okay, so we started by talking about the first condition. Okay, even just before that, we talked about the type of forces. We talked about concurrent forces. We talked about coplanar forces. Then we moved on and talked about the first condition, which is supposed to be satisfied for static equilibrium to be in existence. So we said if an object is to be at static equilibrium or in static equilibrium, first of all, the summation of all the forces acting on the object should be equal to 0. So we said that these are supposed to be resolved into their components. So the summation of the forces in the x direction is supposed to be equal to 0. The summation of forces in the y direction is supposed to be equal to 0. Okay, so we looked at, is it about 2 examples concerning that? Then we said there is another second condition that is supposed to be satisfied for static equilibrium to be what? To be in existence. Okay, let me try to give you a conceptual test to see if people really understood. Okay, let's say there's a magnitude of force here, 10 newtons, putting to the left, then there's also another one putting to the right. Okay. So I want anyone to help us. So we've seen that these forces are all acting in the x direction, and so do we expect this this bar, or maybe this let me just call it a bar. Do you expect this metal bar to be in static equilibrium if we apply the forces like that?
Yes.
No, it can't be in static.
Okay, you can try to give your reasoning, but everyone can get what we're trying to say.
According to my observation, the forces direction is different.
The directions are different. Are they not all acting in the x direction?
They're different, but they're the same. So obviously, it's not going to move.
Are you sure it's not going to move? It will not move.
It will move.
What about the focus? Is that not going to matter?
Pardon?
The pivotal point.
Okay, no, what I'm saying is somebody else, okay, let's say somebody else is holding on top there with an equal force, then somebody else is also holding on the other end with the same force. Is it going to move or it's not going to move?
It will not move.
It will not move.
It will not move.
Okay, that's a good one. So that one will help you understand what I'm trying to say. Okay, so if at all we try to get to, okay, what am I trying to say? So let's try to get the summation of the forces in the x-axis, because they're the only ones that are present. Okay, summation of forces in the x direction. What do we have? Let's consider this one, the left side direction to be negative, not so? So it will be negative 10
Yes, sir.
plus 10. What do we have?
0.
So despite having a 0, the object is not at what? Is not at static equilibrium, or is not in static equilibrium. Are you getting a point, sir?
No, Sammy, I'm not getting the point.
The thing is, we've been saying if the forces, the summation of all the forces is equal to 0, the object is going to be in static equilibrium. Okay, that's what you've been saying, not so? That's what you've been saying. But if you look at this one,
Yes.
if you look at this one, the forces are in opposite directions, and the summation is equal to 0, but still the object is not going to be static. It's still going to move.
So how?
This is going to
Is
move.
it because the forces in the y direction are not there?
Let me just allow somebody to join us. No. So I don't know if you're getting it. It's different when you get a bar. Let's say this one, right? Let's say you're putting it at from the same point, maybe. Can it move? Can it
It will
move?
not move if the forces are equal.
It will not move. It will not move because the forces are equal. So this one, I don't. It's not just. Don't just look at the. Don't just look at the forces there. Okay. Don't just look at the forces. Don't just look at the forces. Otherwise, you get it wrong. So for this one, since you're acting at the same point, it's not going to move. Now this one. Okay, how can I put it? Okay, let's say you're standing this way. Then maybe you've tied maybe a string and you are pulling. Then somebody else is also standing this way. Then is also pulling. Don't you expect that this is going to move like and it so that it lies in this direction?
Yes, it will move.
Now, if you say it will move, maybe you consider the weight of the road. Unless you consider the weight of the load. But if you are not considering the forces, I think how okay. Explain.
Okay. Okay. What am I trying to say? Because I don't know if you're trying to. Okay, let's say this is a bar. Maybe let me try to. Yeah, this is a bar. We're not the action of the points where the force is acting are different. The forces where there. So this one is at the end there. Then this one is also at the end. So somebody is pulling this way and the other one is pulling that way with the equal force. Okay, I want somebody who is refusing to answer this question.
Samir said this will move.
To move. So what is going to happen
Yes.
is that point there is going to maybe get to this position. Then this point is going to get to this position until the forces maybe act this way. That's when it's going to stop moving. I don't know if you're getting the point. Like,
Yes, we get the point.
So now what am I trying to say? I'm trying to say that equilibrium, it's not, of course, it's possible in some situations that when the net force is equal to 0, it's going to be in static equilibrium. But in some cases, it's not guaranteed. All right? Are you getting me? It's not always a guarantee that
Yes, sir.
when the net force is equal to 0, then the object is going to be in static equilibrium. No. So there's another condition that must be what? Satisfied. And then we expect that static equilibrium will be what? Guaranteed. All right. So now what's that condition? That's what we want to talk about this afternoon. So it's what now we are calling the torque. Okay. So we've talked about the forces. So now even the torque is supposed to be, the summation of the torque is supposed to be equal to what? To 0 as well. Summation of the torques that are present are supposed to be equal to 0. So I believe from your rotational motion you covered the torque. Okay. How is the torque calculated? The torque is calculated as what? As a product of force, radius, and what?
What's that?
Sine of the angle. That is the angle of action between the force and the radius. Okay. So that's what we want to talk about. So I want you to know that the torque that is going to be acting and clockwise direction is going to be considered to be positive. Then the one acting clockwise direction is going to be considered to be what? To be negative. Okay, let's have an example. Let's say that bar is balanced on this pivot. Okay. Then there's a force acting this way. Maybe somebody outside this side. Okay. And let's say maybe somebody else is trying to lift this up with a example force of 20 Newton. Then the other on that side maybe is 100. Let me just say somebody sitting the other way is okay, 30 kilograms. All right. So now, what are we going to say? So when you look at this, the metal bar is also supposed to be, we're supposed to take note of what? The metal bar as well. It has got a weight, of course. So the center of mass, so the middle point, of course. All right. So I think let me just try to complicate it just a bit from the starting point, so to get the point just now. Okay. Let's say that is maybe somewhere higher, 20 Newton. Then the total length of this metal bar is maybe, let's say 10 centimeters, right? Or 10 meters. So 10 centimeters. From that end, ten meters, right? Then we say this is where the middle part is, the center of mass of this metal bar. So what is the weight? And let's say the weight of this metal bar is maybe 10 kilograms. Okay. All right. Then the length to the pivot going this way is maybe 4 meters. Okay. So now what I want us to do is I want us to analyze the forces as well as the torques that are present on this type of a diagram. Let's start with the forces. Any forces acting in the x direction? Do we have any forces acting in the x direction?
No.
No.
Okay, let's try to identify the forces acting in the what? In the y direction.
We have the normal force.
Pardon?
Normal force.
We have the normal force. The normal force. Where is the normal force?
The weight. Going upward.
Why are you even starting with something that you are unable to see right now? Start with something that you're able to see clearly.
We have the weight.
The
Pardon?
normal force is given by the pivot PE.
Okay. Are you sure we're going to take note of the normal force in this situation?
No, sir.
I've said identify what you're able to see.
The weight of the rod.
the weight. Uh-huh.
Yes, which is acting down.
So now we're given the mass. Okay, so that is one of the forces that we have, the weight. So is it going to be negative or positive? Because it's going downwards.
Negative.
So let's start with that. Negative 10
Negative.
by 9.8. It's negative. So we've already talked about that one. So this one is taken out of. Then which other force can we see?
Okay, we have 20 Newton.
Okay, 20 Newton. Is it positive?
Yes.
Then what other force?
30 kg negative.
So negative 30 applied by 9.8 because we know mass is not a force. Instead, we use weight. Anything else?
That's all.
That's all. Okay, so that's how you get the summation of forces in the y, right? In the y direction. So this is just a conceptual. We're trying to just see the concept. So that's how you can get the summation of forces in the y direction. Yes?
I don't know if it's the network or what. Yeah.
Pardon? You're not getting me.
Or network. I don't know if you're saying it.
You people, you can't get me? Okay, you can just mute your mic. Are you able to get me?
Yes, I'll get to you.
All right. So that's the way we get to identify the forces. Now, we don't want to talk about that. We talked about that this morning. Let's now try to identify the torques that are present. Okay. So we're going to cancel this
Sir.
one. Yes.
Yeah, I saw a question. It was the same edge. Then the person left end would be 1 meter. And then they're saying there are 4 on each end.
Okay, let me just mute my mic, then
Active.
you can talk. I'm not getting you. You can talk now.
Bring back the board, yes. I saw a question was saying the same road, and then there was a person standing on the road 1 meter away from the left end. And then they were like, there are forces acting on each end. Forces acting on each end. So how should we draw those forces? How are we supposed to draw those forces when they just say there are forces acting on each end? Are they supposed to be facing downwards, upwards, maybe at an angle, or what? Sir, on that one, help me.
I think the best you can do is can get you. Okay, so the best you can do is just to share the question. I think that will help out. Just share the question to the group.
Okay.
Yes. Okay, let's try to identify the torques. If we're able to do that, then that will be fine. So remember our pivot is there. Okay. So there are some questions where you don't have
Get what
there are
was
some
said.
questions that may not have a pivot, and you have to come up with your own. You're supposed to get any point, pick any point to be your pivot. Then you begin writing the torques in relation to that given point. So in this case, the pivot is very clear. So let's try to write the torques in relation to the pivot. Okay. Let's start with this one. Is it acting? Is it anti-clockwise or clockwise direction?
Which one, sir?
I think clockwise.
Clockwise, because it's going this way. So it's clockwise, yes. So clockwise, is it negative or positive?
Negative.
Negative.
So the torque is going to be what? Force multiplied by, and it's negative. What is the radius?
6 meters.
6 meters. Since we know the total is 10, so it's going to be 6. What's the angle?
Nine.
0.
So it's not. Okay, so you look at how. So that one is parallel to the pivot. It's 90. Making an angle of 90. So we don't show it. Sin 90 is equal to 1. So no need of you showing it. Plus, what other torque do we have? Let's look at the mass of the metal bar. It's 10 kilogram. Okay, so how far is it to? Yeah, so how far is it to the pivot?
1 meter.
Okay, so we know. So this is the middle part of the metal bar, which is 5 meters. So therefore, and since we know up to this point, it's 6, so it's 1 meter. So we're just going to say, remember we're supposed to show it in terms of what? In terms of the weight. So it's 10 by 9.8, which is going to be 98. Then is it positive or negative? It's going downwards, which is anti-clockwise direction. Is it positive or negative?
Positive.
Positive. So multiply by 1. Okay, let's talk about that. Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise.
Okay, so this one is anti-clockwise. Are you sure?
It's clockwise.
So it will be negative. 30 by 9.8 is going to be what?
.94.
How far is it from the pivot?
4 meters.
So that's basically the way you identify the torques. So what you're going to see in the questions, some questions are not going to give you the actual length. They're just going to give you in terms of the ratios. Then some questions they're not going to give you, they're just going to give you, for instance, they can just tell you maybe a force there, right? So as you write this formula, you can make it a subject. And when you are told it's in static equilibrium, you're supposed to equate it to what? To 0. So that you find the unknowns. So some questions will require you to use both the forces and the torques. So the other equation that we add, the other equation that we add can be used together with this one to find the unknowns. Okay, so what is important is for you to be able to come up with a pivot, write the torques in relation to the pivot, okay, and measure the correct angles. Okay. Any questions so far? Any questions?
Where I'm behind where they
Pardon?
initially we said when it is going to, okay, sir, I remember.
Let's try to look at this diagram as well. Let's try to analyze the torques. So the question says the use of torque in static equilibrium. A uniform plank of mass MP and length L is balanced on a pivot as shown with two masses, M1 and M2, at the ends. Okay, let's try to work on this one. Okay, so that's our diagram there. We want to look at the forces. Let's go direct to let's go direct to the torques because we already know how to come up with the forces. Okay. So what do we expect to have? How many torques do we expect to have here? Help me identify them just from the diagram.
There is M2.
So with what? M2. So that is the torque. Which other one?
M1.
M1
Mm-hmm.
and the weight of the plank.
And the
Okay.
center.
So that's the third one. So this mass is actually acting on the center there. That's what we're calling torque what? 3. Okay. Anyone with who can see another one? Or these are the only ones? Are these the only ones?
What about MP?
MP is actually the mass of the plank. It was just written on a long point. Okay. That's where top 3 is. That's where it's acting. It's because it's supposed to be on the middle part of supposed to be on the middle part of the plank.
I think there are no other.
Okay. Let's now try to write them in relation to what we have been given. So torque 1. It's going to be equal to what? The force is going to be
Negative.
it's negative. It's acting this way. It's anti-clockwise direction. Is anti-clockwise negative or positive?
Positive.
It's positive.
So, and the force is in terms of the weight. So the weight is given by what? Mg, right? We know that. Then it's supposed to be multiplied by the radius. So if you look at that from this end to the pivot, what is it? What's the distance?
Sir,
2d. So multiplied by 2d.
Yes, it's
So it's of course parallel to the pivot. So it's 90. How about the second torque?
It's moving in clockwise, so it's negative.
It's moving clockwise. So where is it? It's at
Yes.
this point. It's going to, you think of it in relation to the pivot. Is it clockwise or clockwise direction?
Mhm.
It's both.
Going anti-clockwise.
Pardon?
To
They
move
want
anti-clockwise.
And clockwise.
Mhm.
Yes.
Yeah. So think of it in terms of in relation to the pivot. Okay. How far is it from the pivot?
D.
D over 2.
And the last one?
Mhm. It's D.
We are talking of it from the center to the pivot. How far is it? It's D
Are
over
we
2.
talking about T2 or T3, sir?
Oh, I think that's a mistake what we made. So let this one be the second one. Are we okay now?
Yeah.
Then the third torque. What's the mass?
M1.
Okay. Then the distance? D, right? Now
D.
is it negative or positive?
Negative.
Okay. So those are the torques that we have. Any question?
Only one second.
Pardon?
I'm saying to go on there. This one is the arrow divided by 2.
I'm not getting you.
Sorry.
What's your question?
I'm saying distance for to go on there.
Mm-hmm.
Are we not supposed to use the arrow divided by 2
Distance for torque 1.
for to go on?
How are you looking at it? Because we are trying to find the distance from the end to the pivot. From this point, let me use it. From this point to the pivot. Yes, you're thinking of it in terms of what? A over 2. Because A over
Yes.
2 is just saying it's a middle part. Now, we don't consider the middle part, we consider the pivot. So from that point to that point, which is clearly shown to be this one. Are you able to see now?
Or where is it? Sir, I'm behind.
Yes?
How are you knowing that that thing is going the clockwise or the clockwise direction?
Good question. Hey, the people who are contributing, answer that. Okay, so if I was to ask you a question, how does the weight act? Does it act upwards or downwards?
Downwards.
Okay. So now think of the pivot as the center of the clock, right? Are you getting me? Think of the
Yes,
pivot.
Yes.
Think of the pivot as the center of the crop. So now this one is going to be this way. So what happens when it goes down? Is it clockwise or anti-clockwise?
clockwise.
So that's why we're saying it's negative. All these other points are on the left and they're all going down. Which is what? Anti-clockwise direction. So are you getting me?
Yes, sir. No. So the last one there, T3, is it negative or positive?
It's negative.
Oh, all right, sir.
Mhm. So are you aware of how we've come up with the talks? So this is a clear this is clearly showing you how the talks are acting. So you know the weight always acts downwards. Okay. So we talked about this this morning. That is the first condition, which is a very simple example. Okay, now let's look at a bit more complicated example. This one.
Sir,
Yes.
can you share this document in the group?
Or this document. But not now because I don't have access to my WhatsApp now. I actually don't have a phone now. That's
Maybe
why
tomorrow.
okay, sure. Okay, sure. So it's even indicated another other okay. So now what's the question saying? The question is saying what is the tension in the T in the cable? Okay. Let's try to attempt this one. And if we are able to analyze this one correctly, then we should be able to now answer questions on this topic. Okay. So what I'm doing here is I'm not solving questions, but I'm doing analysis. I want you to be acquainted with the analysis of you being able to use the concepts to analyze the situation that you're given. Then if you're able to understand the way we're coming up with the formulas, it will be very easy for you when we get to look at the questions. Okay, so let's try to understand the question, the situation that we've been given. So a store sign with a mass. So this is of course, this is what? The store sign. Mike is cafe. Okay. So how did they put that? What did they do? They had connected a certain bar. Okay. Maybe I don't know if this was just a hole, then they had to, fix it. Honestly, they had put a hinge there. Okay. Then they connected it. Then it was tied maybe with a rope, okay, or a cord again to the same wall so that it balances. Then from there they connected what? They connected the sign. Okay. Are we able to see all what I've said? That's just the analysis of the situation that we're given. Okay. Are we okay with that?
No, sir.
Okay. So there's a O this side. Okay. So maybe they had to fix, maybe put, maybe they dug like a small O, or maybe they just had put a hinge. Yeah? So they connected the Chimeto bar from this way. Okay. That's what they did. Then this Chimeto bar was tied maybe with a cord or a rope. Maybe they tied it again to the same one. Or maybe I don't know if this is or just a pole. Okay. Maybe it was a pole. Okay. So then this
Probably poor.
the end was tied to that. Okay. Uh-huh. So now what they had to do is they had to now to hang the store sign from somewhere there. Maybe they tied it there. Okay. That's just a store sign. Have we understood now? Are we able to imagine what is on the ground there? Mm-hmm. So that's what we have. So now we try to analyze this question as people take physics. Okay. So we've been given the distance, the length from the pivot. So they are saying we consider the hinge here to be the pivot. All right. That's what that is telling us. Consider this point to be what? To be what? Your pivot. So now let's try to identify the forces first of all. Let's try to identify the forces. So when you resolve this tension into its x and y components, what are you going to see? You are going to see that there is a tension putting it upwards. There's also the one in the x direction putting it to the left. So another force is the weight of a bar, which is acting downwards. Then also the weight of the sign itself is also acting downwards. Any other force that you're able to identify?
The tension itself.
I've already talked about the tension because I've resolved it into its x and y component. Okay, so the y and the x components of the tension are representing the tension itself. Okay, because remember we said when you're dealing with the forces, you need to resolve them into their x and y components. You get me?
Yes.
Yeah, I don't want to rush. That's why
Yes.
I'm just chilled. I don't want to rush because you need to understand step by step this topic. Okay. So now let's try to now analyze the talks. Okay, how we can write them in relation to the point that we have. Okay. So there are some situations where you're going to be told the O is also maybe acting. So when you have this situation, there is a force. There's a force that acts this way. Okay. So the pole of the O may also push that bar. Okay. And there will also be a force acting upwards along the same pole. Okay. So now those forces, what I just want to highlight is that those two forces don't have what? Don't have a torque because they're coming directly from what? From the pivot. Those two forces don't have what? Don't have a torque because there is no radius here. The radius is 0 because they're acting from the pivot itself. So now, from the forces that we've identified, we've identified the y component of the tension upwards, which we are calling Cy. Then we've also identified the x component, right? So let's start with the 2. If you talk about Tx, does it produce any torque in relation to the pivot?
No.
No. So anything
No,
parallel.
that is producing.
Yeah. Okay. It's not producing anything. It's not going in there. It's not moving anti-clockwise or anti-clockwise. It's parallel to the metal bar. So it doesn't produce any torque. So we're going to focus on the y one. Okay. So what is the y going to give us? The torque. First of all, let's try to write it in terms of a force.
So it will be
Let's write it in relation to the angle theta. Ty what?
T sin theta.
T
T
sine
sin theta.
T sine theta. That's the force. So now in terms of torque, how is it going to be? Okay, let's just write these at the same time. Okay.
T sin theta times J.
Times what?
Different.
Okay, so we're trying to measure the length from the pivot to the point of action. It's L. Okay. Is it negative or positive? First of all, is it anti-clockwise or clockwise?
it is a positive, sir.
Okay, so it's anti-clockwise.
It's going up positive.
Then let's talk about the sign itself acting at this point. And we're told the mass is what? mf. So is it acting clockwise or anti-clockwise direction?
It's acting anti-clockwise. It's acting clockwise.
So it will be
because it's
negative.
going down.
I don't want you to use the word because it's going downwards. How about if you said we are the force acting downwards this direction? Is it going to be clockwise?
So since the mass is right of
Okay.
the pivot, so you have to go clockwise.
Okay. So let's try to talk. So it's going to be in terms of the weight because it's a mass. So ms multiplied by gravity. Then how far is it from the pivot? We are told it's 3/4, right? 3/4 L. Are we together?
Sure, sir.
How about which other talk do we need to talk about?
The weight of the same.
Okay. So now we're told the total length of the metal bar is L. So we expect it to act on the middle, right? Because it's the center of what?
Yes, sir.
The center of mass. So is it going to act, because it's also acting downwards, is it going to be clockwise or anti-clockwise?
It is also going to have negative side.
So the mass is given by mb. That's what we are told. It's the mass of the bar. Then multiplied by the gravity. Then how about the length?
Half.
L/2.
Okay, over 2. So we know that this is like supposed to be for the signpost, for people to see, it's supposed to be in static equilibrium. So you're supposed to equate this, all this, the summation to what? To a 0 there. Okay? Are we together? Are we together?
Yes.
Okay. So our goal is to determine the value of tension, this T. So you've seen that L is common, right? So you can cancel it, and cancel it. So we're going to remain with T sine theta multiplied by 9.8. We are trying to substitute the values of what? Gravity now. Multiplied by 3/4. What are we going to have? Then MB multiplied by 9.8 multiplied by 1/2. Help me with the values, huh?
Seven point.
Which one?
The first
Nine.
one.
First one is what?
7.35.
Okay. 7.35. Okay, let's just take it the other side directly. So it's going to be positive. 7 point. 7 point what?
35.
So by ms plus 9.8 divided by 2, 4.9.
4.8.
4.9 MB. So in this case, we are not given the mass. The masses, we are not given the angle sine theta. So you can just read the solution in terms of the same. Okay.
Sir,
Yes.
why has 4.9 become positive?
Okay. Who is able to see why it has become positive?
It is
Equal sign.
on the right hand side.
Okay, I see the equal sign.
Okay. So that's the analysis of this situation that we had here. Any questions about it?
Yes, sir. I have a question on in theta multiplied by length. A credit on that point.
Sine theta?
Yes, sin theta multiplied by
Multiplied by L.
yeah.
Okay. So when it comes to the torques, we are trying to determine the radius. Alpha is the same force in relation to what? To the pivot. So when we resolve the tension, we had Ty. Okay. So Ty, what is Ty? Ty is actually going to be what? Because look at this theta. So Ty is more like the opposite side there, right? If I want to.
Yes, sir.
So it's going to give you what? It's going to give you T what? If you use the trigonometric
Sin
ratio, sine theta. You're okay with how that is coming about?
Yes,
Mhm.
sir.
So now, how are we getting the L? We're trying to measure how far it is from the pivot. So if you look at the bottom there, we are told it's L. From this point to the end, it's L. That's how we wrote it. Because for the torque, we're multiplying
Or
the
at
force.
uh,
Pardon?
now I've seen.
Okay. Any questions?
Sir, for that we just have to come up with the same analysis rather than finding the
We're supposed to do what?
we've asked to find the chain.
We've been asked to find what?
Been asked to find it. Just you finding formula.
Okay. You can ask me. I wasn't getting you. You can ask now.
Sir, so on since we are told to find the tension,
Mm-hmm.
we could find it if we are given masses, right?
Yes, that's what I said. Okay. Talking about the forces. What forces are we going to have? So I said from the pivot there's a force acting along the pole upwards. Then there's one acting to the right, the x direction. There's the weight of the metal bar. Then there's the weight of the sign. Then the tension, the x and the y direction. Okay. So when you look at the forces in the x direction, so when you look at the forces in the x direction, so what are we trying to say about the forces in the x direction? Forces acting in the x direction, there's this one, this way. Then there's also the x component of the tension, which is this way. So these are the only two forces in the x direction. In the y direction, on the other hand, we have there's one this way. There's the tension. Then there's also this going downwards. So these are the forces in the y direction. So you being able to see that is very cardinal and very important. So if you look at that, of course, you're supposed to take note of the signs. Okay. Let me just try to talk about the signs. The ones going downwards are going to be negatives, right? Negative, negative. The ones going upwards are supposed to be positive. Okay with that? Then the tension force pulling this way is supposed to be negative. Then the other one pulling this way is supposed to be what? Positive. Are we all okay with that?
Yes, sir.
Okay.
Okay, sir, I have a question.
Yes, sir.
Is it always that if an arm downwards, it's negative and points up.
You're asking about the forces.
Okay.
Okay, so the way we come up with signs, when it comes to the forces, we use the XY plane. All right? Going downwards, it's a negative axis, negative Y axis, so it becomes negative. Going upwards, it's a positive X axis, positive Y axis. Going to the left, it's a negative X axis. Going to the right, positive X axis. Now,
Thank you.
mhm,
Didn't know that.
okay. When we talk about the talks on the other hand, we use the clock to come up with a sign. Okay. So we come up. So the center of the clock is the pivot. So everything going downwards from the right direction is considered to be clockwise, and they're going to be negatives. Anything going upwards on the right hand side of the pivot is going to be positive because it's anti-clockwise. Including the things from the left going downwards, they're going to be positive. On the other hand, from the left going upwards, it will be negative. Are we on the same page?
Yes, yes.
So according to what I planned, I'm done with the topic. So what is remaining is just a tutorial session to solve questions now, unless if there are any questions. It was supposed to be a tutorial session,
Sir.
but we didn't finish it. Yes.
So you mean anything that is before the pivot and it is on the left side? So it means it is positive.
Anything that's what?
Anything that is before the pivot and it is on the left side, does it mean it's always supposed to be positive?
I don't know what you mean, which is before the pivot.
Like, I mean, the left side and the right side.
Okay, so which one are you picking? Are you picking the left or the right hand side of the pivot?
Like, we pick the left side. Is it supposed to be positive always?
No, it depends. Is it going upwards or downwards? Okay, let me try to answer that. I don't want to, let me answer you properly. Okay, let's say the pivot was somewhere in the center there, right? So you're asking about something being on the left hand side. So if we are the mass here, right? We expect it to go downwards. So when it's going downwards, is it clockwise or anti-clockwise? From the left, like this.
And
Anti-clockwise. So it's going to be positive. So if there was a force pushing this upwards, it would be going this way. Would it be clockwise or anti-clockwise?
Clockwise.
So on the left, it's possible to have a negative and a positive sign, depending on whether it's going upwards or downwards. All right?
All right, sir.
Okay. Any questions? Any questions? Okay. So let's do well to have a tutorial at 21 hours. If you're going to be available, 21 hours, we can solve questions now. Because we are supposed to have a tutorial at 17, but because we didn't finish, we had to finish up.
okay, sir.
Okay, so let's have a tutorial at 21 hours. The people with questions, you can share them in advance to the group. All right? Okay.